Is sharing okay?
Yes.
Yes? Okay. So, we are all set. Wine, Nico.
So if we can shorten the coffee break, and maybe you can drink your coffee while watching the next presentation. Let's look. So the next presentation is by Professor George Antonio on the 4D lattice IIR filter design. Atman.
Yeah, hello. I welcome all of you to Athens. Me too. My presentation is about filters. Double E. Okay, the first part, 0. We're going to see about a review. What is this? And the required background for that. So I'm going to talk about the conventional 2D basics, talk about state space models for conventional and 2D. All this can be extended to more dimensions. Like I'll explain to you why this is very important. Now, the part 1, I'm going to talk about 2D. This way you can see the results from the beginning. And after this, I'm going to talk about 4D. Now, to go from 1D to 2D, it is not an easy task. The same way to go from 2 to 3, it is not an easy task, and so on. And finally, talk about the conclusions. Okay, 1D, 2D, basic knowledge. 1D, example. Okay, function of one variable, 2x plus 1. This function has a root, correct? Also, this is the quadratic. This is 2 roots from high school. Therefore, 1D, it is voice, the conventional signal. 2D dimensions. 2D, 1, 2x plus 3y plus xy. 2 dimensions, okay? 2 variables, 1x, 1y. Also this is another function, 2 dimensions. What is a 2-dimensional system? It is an image. Okay, fundamental. Okay, it is known from Gauss that 1D polynomial of degree n can be factored into product of n polynomial of degree 1. So therefore, we can find roots. But for 1D polynomials, finding the factors, it is equivalent to find the roots of the polynomial. Example. For this, it is counting to find the roots easily. It is 1, 2, I'm sorry. For this, it is 1, 2, 3, and 3, double. But there is a fundamental theorem of algebra for 2D, 3D, 4D, and so on. So 2D are the applications for images. Very important. Okay, so 2D and ND cannot be factored, so therefore there is no roots. Now what? Only you can factor for special cases, not in the general case. So therefore, we don't know if it's a special case or not. Okay, so for example, this 2x, 2y plus 6. So this is 4x, 3y plus 12. Those have roots, but those actually are not 2D polynomials, are 1D polynomials. Because this is x plus 2, y plus 3 are 1D. So therefore, we can apply what we know. The absence of the fundamental theory of algebra, it is very significant. Why? Because not all known 1D algorithms, methods, and techniques can be applied to 2D, 3D, 4D, and so on, ND polynomials. Therefore, we have to propose new theorems, new algebra, new mathematics, which is not visible, okay? It is invisible. So algorithms and methods and techniques for 1D minimum state space realization cannot be used for 1D and MD system and filters. Review. 1D state space systems. What is this? This comes for control systems. AA. Okay, we have 1D state space, conventional, analog. We have 1D state space, digital. Okay, the continuous 1D, it is this, where the U is the input, Y is the output, and this is the state. This is what we learn in linear systems. So this is the analog, and this is the digital. Now, I plus 1, A, X, I, this is the U is the input, the Y is the output. We apply the Z transform, the conventional 1D, and we find, okay, the numerator and the denominator of the filter. 2D. Now, we have three models. One that is the Bonnie-Roser, and I'm going to introduce a new modified one for my filter. Okay. So therefore, the first one was introduced in IEEE transactions on computers, and this has 1 plus 1, J plus 1, which means vertical and horizontal, okay, an image. And this is the input, and this is the output. So therefore, we can make a condensed form of the model. So therefore, this is the horizontal, and this is the vertical, only top and bottom. This is the initial model, okay, and the matrices. So this is the Bonnie-Roser, the classical 2D space model. Okay, now, again, the same thing, we can apply the 2D transform, and this is, again, the transfer function with the Z, it is all the Z's on the top, Z1, Z2 on the bottom. Okay, my model, it is a little bit different. The same idea, like the Roser, but the variables are x1 h, x1v, x1a, x1v. So therefore, it is something that interchanges. And why this? Because it allows me to generalize my result. And again, applying the 2D Z transform, but in this case, the diagonal Z1, Z2, Z1, Z2. This is in 2D case. In a 4D case, this is Z, Z1, Z2, Z3, Z4, Z1, Z2, Z3, Z4, and so on. 4D filter. Okay. I carry work today. I'm going to introduce a mixed lattice IR filter, which means it has the numerator and denominator. And why I talk about minimal? Because it's not only because of the hardware requirements, but non-minimal realization cause theoretical and also computational difficulties. Okay, so therefore, minimal are not always possible even for 2D. So therefore, I talk about 4Ds, and always the dimension of the state vector is minimal. Also, the circuit, it is minimal delay elements. Okay, so therefore, I will talk about only first order 4D, which means 4 by 4. A 2D, 2 by 2. Okay, 2D port. So therefore, this is an 1D. Okay, 1D lattice, conventional, because you can see the arrows go left and left, left and left. Okay, this is what we learn in linear system. This is the basic lattice 1D filter. Okay, now there is also another one, which is not in the textbooks. Okay, so therefore you can see I have this to be a right, 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 and a right barrel. So therefore this is a different structure, but has the same transfer function. 1D port. For this 1D, we can also have a mix where the left, it is left and left, right and right. So therefore, this is what I extend to 4Ds. And this is what we know. The top, it is the left convention. This is the right, or inverted. And this is the mix. The mix goes left and right. So therefore, this is the mix 2D. We write the equations, okay, by extraction. We derive the minimal state space model 2 by 2. And also at the end, if we apply the Z transform, we can find the numerator and the denominator. We can see that this is correct. The numerator and the denominator are mirror images. Delta 1, delta 1, delta 2, delta 2, and 1. We have all four this way. Also, another way you can see around is this. Okay, so therefore, the blue, the green, and the red, which means the 2D preserves the 1D conventional property. Okay, now this is 4D, mixed. This is my filter, okay? This is my new result. Okay, in this case, it is mixed at the left, it is mixed at the right. So this is a left, right structure. Again, I extract the equations from the circuit. It is minimal, and this is, you can see, HDD, HDD is one order 1. This is 4 by 4, which is minimal, the state space. And also, we can see this is a transfer function, the reflective structure. You can see this is the gray code, C3 and C4. They have the same coefficient. And for the audience, I made another way using binary numbers. You can see the numerator, the denominator. You can see at the top, as I progress, the blue, the red, the green, the same, the blue, the red, the green, the blue. Delta 2 is the same. Also, the other way around, it's symmetrical. I can go up and down, so therefore, you can see that this is a mirror image of the numerator and the denominator. So therefore, the 1D structure, okay, applies to 4Ds. And this is also another structure that I have. You can see the left and the right, also the top and the bottom. So therefore, the top and the bottom, the red, it is the same. You can see 1, delta 4, 3, 4, 3, 2, 3, 2, 4, and 2. Also the other way around, delta 1, 1, 4, 1, 2, 3. So therefore, this is also a correct transfer function for the given 4D filter. And finally, okay, this is another form. You can see, okay, up and down, that the coefficients are equivalent for the numerator and denominator in a mirror image structure. This is also, I didn't analyze the results because this is only order 1. So this is the straight space, the realized straight space matrices for N, where A, B, C, and D are the derived matrices, and then the community. In this study, a new 4D lattice all-pass filter having mixed right and left directions has been presented. The proposed 4D circuit uses a minimal number of delay elements. The dimension also of the state vector is minimal, and the resulting 4D transfer function exhibits the well-known 1D all-pass mirror image lattice characteristics. Okay, now, what is so important about this? Using the multidimensional framework, you can redesign high-order 1D filters, which is not possible. Up to now, everybody uses 1, 2 the most, 3 the most. They don't use 4th and 5th order 1D filters. Using this technique, you go from behind, okay? You derive the 4D, 5D transfer function, and then by making Z2, Z3, Z4 equal to 1, you can go back to 1D, and then you can increase the size of the filter using the transfer function. The only drawback, it is you have to invert matrices that have characters, which is very important, okay? And you must write specialized program in Java or Python. Okay, thank you for your attention. Questions?
Very sound question.
Yes, application on your method on 4D.
Okay,
With,
normally
with
1D, 1D, it is the voice. 2D, it is an image. 3D, it is a movie. 4D, virtual reality. It is 3-dimensional one.
virtual reality.
Okay? This is mathematically, it is possible. Okay? In a human beings, we don't see the 4 dimensions.
Science, I mean, the application.
But you can write programs, okay, to do all this.
And the time of processing?
The time processing, for now, a 5D, a 6D crashes. Okay, up to 5D is okay. 5 years ago, you could do only up to 4Ds. Today, you can do 5Ds, 6Ds, only the denominator. IIR, only 5Ds. Can work for 2 days and no result. Questions? Thank you.
If my information are correct, we are changing order.
Yes, sir.
Presentation. Next presentation is the impact of digital technologies in education.
Digital.
And presenting is Cecilia.
Hasaya. I will try to. Okay, before presentation is ready, I would like to welcome everybody and want to start the presentation with gratitude to Ukrainian friends and Greek friends for giving us the opportunity to attend this amazing conference and to visit this amazing city and to get inspiration from this Greek culture that we just look around. So thank you for this opportunity. Thank you. So,
I just wanted to ask.
yes.
So, Artemis, the sharing okay?
Yes, everything is clear.
Okay, I represent Georgia, to be more specific, Batumi State University. And I would like to present an article on which we're working, the whole team of our university, and some of them are here presented, like Ibrahim Bidmanidze, Dario Borginitze, and Zeburi Beridze, and including me, Iya Hasaya. The topic of our presentation is the impact of digital technologies in education. So after listening to so many formulas and so many mathematics and coding, we will move to a little bit education and problems within the education system and cybersecurity. So in today's digital age where technology is an integral part of our daily lives, the importance of cybersecurity kind of cannot be overestimated. With an ever-growing reliance on digital platforms and the increasing sophistication in cyber threats, it is imperative that the individuals, organizations, and governments take cybersecurity more seriously. Higher education institutions play an important role in preparing the next generation of professionals, equipping them with practical skills, knowledge to navigate the complex of cybersecurity. Okay, cybersecurity is not just a concern for information technology specialists. It's a concern for everyone. From banking to healthcare to social media and national security, virtually every aspect of our lives is connected to the digital realm. This interconnectedness exposes to various cyber threats, data breaches, ransom attack, identity theft, and many others. But in this context, the higher education institutions bear the responsibility to ensure that students and graduates of our universities gain practical skills necessary to combat any threat effectively. I'm going to discuss cybersecurity curricula and programs that are included in our university program. Because to address the demand for cybersecurity expertise, many higher education institutions now offer dedicated cybersecurity programs and courses. And these curricula cover a wide range of topics, starting with network security, ethical hacking, cryptography, digital forensic, and many others, and They try to cover areas and topics commonly included in cyber security curricula. It can be incident response, which this is an area that focuses on how to handle and respond to security incidents and identify breaches, including identifying and containing and mitigating security threats. It can be security architecture and designs, security compliance and legal issues, cloud security, wireless network security, security risk management, secure development and coding, social engineering and human aspect of security, industrial control system, ICS security, mobile device security, biometric security, cyber security policy and governance itself. So these advanced subjects and specializations within the field of cybersecurity offer a more comprehensive and specialized education for those looking to pursue careers in various aspects of information technology. And by offering these courses, institutions are ensuring that students receive a well-rounded education. And one of the key aspects of promoting practical skills in cybersecurity is providing students with training opportunities. And many universities around the world, including in Georgia, have established cybersecurity labs where students can engage in real-world situations. And they can test security measures, develop practical skills, a kind of controlled environment. And these labs not only build technical expertise, but also foster a kind of problem-solving abilities in critical thinking, which is very essential in this field. Beyond the classroom, internships and cooperative education programs provide students with a kind of valuable real-world expertise. And this collaboration with industry and partners and government agencies allow students to apply their knowledge and skills in an actual work setting. And this is very important opportunity because it gives a student a taste of challenges and responsibilities they will face in their future careers. As for ethical, just a moment. Okay, no, this way. Consideration of cybersecurity, education should not be limited. It must encompass the ethical and legal aspects as well. And students must understand the importance of ethical behavior in cyberspace and the legal implications of their actions. And we as educators play a crucial role in instilling this principle in our students. One primary goal of higher education is to foster research skills among students. And university utilizes and offers a kind of plagiarism detection programs. And one of them is a kind of Moodle we are going to discuss today. And they serve as a valuable resource for educators to teach students about proper research, citation practice, critical thinking, and generally development of original thought. So the programs can be leveraged to promote students' research abilities like educating on academic integrity, teacher proper citation, promoting critical thinking, enhancing academic writing, encouraging ethical behavior, even peer review, building confidence in guided use. And this incorporating plagiarism detection programs into educational process can serve as a catalyst, enhancing students' research abilities. And when used teaching tools, these programs help students become more proficient researchers, writers, critical thinkers, while fostering a strong sense of academic integrity. And I mentioned Moodle. It is one of the most popular open source learning management system used by educators worldwide, as well as in Georgia. It is created to manage the online course. It can be integrated with plagiarism detection tools to help educators identify and prevent plagiarism within student assignments. And this integration provides a comprehensive solution for managing educational content, tracking student progress, ensuring their academic integrity. Why Moodle? Moodle because it can use in conjunction with plagiarism detection tools like plagiarism plugins, assignment submission, originality of the report, teaching opportunities, feedback and revision, enhancing academic integrity. And while Moodle can integrate with plagiarism detection tools effectively, it's important to use these tools in an educational context, promoting ethical behavior and fostering a culture of learning. And the goal is not just to detect plagiarism, but to educate students about proper research and citation practices, and encouraging them to thinking more originally and to be academically more honest. So, what is the advantage of Moodle, especially for countries like Georgia? It's first of all cost-effective, open source, and it allows institutions to save money on licensing fees, making it more budget-friendly option. Customization, because it allows institutions to tailor to their specific needs. Easy to use, that is very important for students and educators as well. It allows content management. They can upload, organize, manage course content, include text, images, videos, quizzes, assignments, and more. It provides collaboration because it increases communication, interaction among students, making students and teachers cooperation more facilitating. It allows opportunity for assessment and grading, tracking and reporting. It's more accessible because it complies web accessibility standards, ensuring that all students, including those with disabilities, can access and engage with this platform. It's more secure because with regular updates and large user community, it's helpful for identifying and addressing security vulnerabilities just properly. Thus, Moodle, we can finalize it as a kind of powerful and user-friendly learning methodology system that offers numerous advantages in higher education. As I mentioned, it's cost-effective, customized, easy to use, and it offers a wide range of features, making it valuable tools for educators and students alike. It is essential to strike a balance when using plagiarism detection tools with Moodle. While the primary aim is to maintain academic integrity and deter dishonest behavior, it's equally important to use this as an educational aid to help students improve their research, their writing skills, their citation skills. And when integrated thoughtfully and used in a constructive manner, Moodle and plagiarism detection can contribute to a culture of academic honesty while fostering the development of research and writing ability skills. Not to bore you with my article overall, I would like to mention what methodology we tried to input in our research. It was quantitative as well as qualitative research, and we studied the data, we collected it, made analyses, we interviewed our students on the use of different programs and made an online survey as well. And so actually the paper complies with information for educators, providing recommendations as well. So to summarize, the digital landscape continues to evolve, and higher education institutions and educators must remain proactive in shaping a cybersecurity education, interdisciplinary approaches that combine cybersecurity with fields like law, business, psychology, and they can better prepare students for multifaceted challenges of the digital world. So, and by actively engaging in these activities, higher education institutions and educators can contribute significantly to the promotion of cybersecurity, helping to build a safer and more secure digital environment for individuals, organizations, institutions, society as a whole. So that's it.
Questions?
Yes, welcome. Yes, please.
Thank you very much for your presentation. I have two questions.
Yes.
First one, what about any metrics which could help us benefits or advantage or disadvantage any approach? Because the main focus of your presentation was dedicated to application of Google.
This just one, yes.
Just one,
yes.
because there are a lot of different
Of course.
platforms. The main your message related to application Google or any other as a platform?
Yes.
It's my second question.
Mhm.
Metrics and the message concerning application education platform, because in condition of COVID time and our motion to virtual world, this problem it becomes more and more complex, and we can
Yes,
about
obvious.
not only safety critical, we can talk about education of critical education.
Yeah.
Simple.
Okay, so generally, the problem of, I don't know how it happens in Ukraine or Greece, but in Georgia, the basic problem we discuss technology and education in combination is that we have a problem not only about the Moodle, but generally about the technology overall. So we are trying to, and you are right, during pandemic situation, we started using a lot of online platforms using for interaction and promoting, and not to stop the education completely. Because if before pandemic, we just use the technology just for appliance, then we started using it and it became the platform helpful for spreading education and interacting with students. So Moodle, it is used just for assignments, as I mentioned. But we, as a whole, we use Team in our country and Zoom for interacting with students, and very helpful platforms that help us to conduct lectures. And at university, we have other platforms as well, because we have programs that give us opportunity to interact. Even in this face-to-face relationship, we use these platforms for informing them, for uploading material, for getting assignments as well. So Moodle is much more helpful.
What about the metrics? Any quantitative assessment in point of view to assess efficiency of different platform or different technologies?
Yes. Actually, we make a survey within the university. I mentioned that we have BESSERT platform where we are just openly, and it is a kind of, how to say, which word to use, when we interview students on the efficiency of the programs that is applied at university. They are a kind of honest students, and they make many critical comments to update it. So Moodle is one, as I mentioned. I forget the name of the program we are using at university. So it's open source, where we make a survey among students. If I open up my platform, I can see how they estimate my work as a teachers, how they estimate overall process of university process, academic level, and even exam, lecture, resource, everything. Students are open to criticize and estimate the whole process of university working. Then we have a kind of authority that checks this everything. It's anonymous, absolutely, for students, and students openly collaborate with our authorities who is checking how students can see it. And by the way, in our research material, we use their kind of comments and their responses on our survey, how they see the necessity of technology, how should be updated for their use, actually.
Thank you.
Thank you. Thank you. Maybe I don't think I did this correctly. Okay.
I have one question or
Yes, okay.
recommendation, because in this study do not consider reliability of the system. Moodle is old and it's a prehistoric language.
I understand what you mean. I mentioned that the difference between members of EU and developing countries is different. For you, maybe Moodle is a kind of, but for us it is not, unfortunately. And I admit that. That's why I just made an overview of the Moodle, did not go into details, but it recently established in our university.
But on university we use Moodle too, but maybe it's terrible and hard with a lot of students. say.
I see, but just as I mentioned, usually the goal is to make them more academic and more honest, avoiding this plagiarism, as I mentioned, because it is a problem. You know how it happens. You give assignment to students or ask them to participate. They copy paste, and bring you some copies from internet. And to avoid it, Moodle is one of the mechanism that is helpful for us to help to make them to change the attitude. Because until the homework is accomplished, we are not giving them the score, and they have to work on themselves and come to us, collaborate with lecturers, and we teach them how to be more honest about citation and how to try to not to be just. This is very important. Thank you.
Thank you. Next presentation, presenter is Jakub Reczny. Theme of presentation: analysis of eye surgery outcomes to predict patients' quality of life using statistical reasoning.
Ladies and gentlemen, allow me to introduce the
Maybe
topic
use
of our...
microphone or
I could do that.
The problem is possibly transfer this
Should I see?
event online.
Should I see it then?
yes.
Okay. Then I will see.
It says that this is where they don't validate.
Okay, then.
Własniejsze. Ten używają do własnych.
Once again, ladies and gentlemen, allow me to introduce you to our topic of our research. And before we start, I will introduce the interesting problem in this research, and that's how to predict the outcome of eye surgery. Every surgery comes with a certain level of uncertainty, and also how to choose the right type of surgery for the right patients. Because if you talking, for example, about eye surgery, then one problem with the eye can be solved with different surgeries, and every surgery comes with its own advantages and disadvantages. So choosing the right surgery for the right patient is quite important. And this can be also done manually, but this process is very complex. It takes a lot of time, and it's also prone to human error. And because of this, we propose a solution to categorize the result of operation based on various factors for the individual patients, and we choose to do this by using a decision tree. And so we have a better understanding what a decision tree is. You can see this simple diagram. It is a hierarchic tree-like structure that consists of root node, branches, internal node, and leaf nodes. And to more about decision tree, it's a non-parametric supervised learning algorithm, which is used for classification tasks as well as for regression tasks. It's useful for data analysis. For example, regression trees are used to predict stock prices, and classification trees are used to label certain data into a certain class. Probably the most famous example is classification of pictures, dogs and cats, and pretty much algorithms told us which picture is cat and which is dog. But medical professionals usually term in terms of classification, such as low risk and high risk, and because of this, we decide to use a classification tree in our research. And without going into too much details, the classification is a process of predicting a variable epsilon that takes value 1 to k, and based on a p predictors x1 to xp. And the goal is pretty much to find the value of epsilon based on the value of x. And tree structures in this situation can be quite beneficial because tree structure is adaptive to multiple variables and is also quite easy to visualize. But before we can build our tree, we first need to choose our invariant splitting criterion, and this refers to a criterion where tree is built based on the value of a single attribute, and there is also a numerous approaches to select optimal variable. For example, info gain, Gini index, or gain ratio. Those are most prominent in this area. And for purpose of our work, we choose a Gini index. And now just quick description of the project. We implemented R3 in programming language Python. Only third-party libraries we use were NumPy for mathematical operation and pandas for data manipulation. As I mentioned, as a splitting criterion, we choose Gini index, and data for this research were provided by a private eye center in Žilina. It contains records of 86 patients and 156 different eye surgeries. Some patients had both eyes operated, some only one, but for the purpose of this research, we consider every surgery as an individual. And the measured factor were diopters, cylinders, axis, but also some information about the clinical procedures, for example, use lenses, type of operations, and so on. And before we could start experimenting, first we need to split our data into several classes. We did the splitting based on patient vision, based on improvement in patient visions, and the values were based on Snellen chart, which takes values from 0 to 1. You can also see the example of Snellen chart on the picture. 0 means that the patient couldn't read even the biggest letters, and 1 means he could read all the letters. And 6 parameters is represented as a number, 1 or 0, and we also choose maximum depth for 3 to 3. So it's relatively simple and easy to read. And in the first experiment, we just took the data for all the patients and pretty much see what happens. And as you can see, the visual accuracy before operation was quite important, because patients with relatively good visions before operation don't have such a big room for improvement. And because of this, in our next experiment, we choose only patient with value of vision accuracy less or equal to 0.5. There were 119 such patients. And as you can see, the variable visual accuracy is still relatively important, but not as much as it was in previous experiment. entered the experiment, we added an additional variable type of surgery that was either cataract surgery or refractive surgery, and we also represented this value as a number, either 1 or 0. But we very quickly discovered that this value has pretty much no effect on our decision tree, even if we increase the depth of it. But before we say that this variable had no effect on result of the surgery, we decided to split the data into two groups based on type of surgery. And as you can see, for the individual type of surgery, two different trees were built, and also different factors are important in individual trees. So it's so the type of operation have quite a large effect on the outcome of the operation. And then we also conducted some additional experiments which we tried to also add factors of type of lens which were used in operation, but once again we had a very similar result as in the first experiment, and after a closer examination of the data, we discovered that the majority of the lens were of single type, more than 19%. And we encountered the same problem when we added another factor, flex or femtosecond cataract surgery, because we have only 4 instances in our data where this type of surgery was used, and that's simply not enough for any reasonable data analysis. And in conclusion, we showed the possibility of using decision tree to predict the outcome of the surgery. So this could be used for healthcare provider to improve their ability and provide a better services for patients. But most importantly, we shows how important it is to gradually collect data, and not only for other researchers, but only for other medical institutions. And that's be all. If you have any question, you may ask them.
Some questions?
Yes. Thank you for your presentation. My question is, it is a decision support making system. Yes. This your project can be
Start of study.
start of study, research plus some development. What about your planning certification of this program? And it's needed according to this future certification and get us for practical.
I answer. For this first analysis, we are preparing starting this study, and if it's better after this surgery and making this implant, it's better vision, then we continue creating a system which can add some patient's data, and the result of the system maybe is value, or maybe some percentage, say, if this surgery is helping, or and this is a mix of this is our first concept.
And then the second question related to what about privacy protection? This case, because you use
Yes.
real data.
These are real data, but firstly it's anonymized from all doctors in the team, and this anonymized data is required edit to patient in ambulance. Thank you. Our next presentation, presenting Linda Blachova, and name of presentation is blood smear leukocyte identification using an image segmentation approach.
So we want this one. Hopefully. This one. Yep. So, and we should share as well. And this one. Yes. Okay. And you are good to go.
Stage is yours.
Thank you. Okay, so hello everyone. My name is Linda Blachova, and I'm thankful to the opportunity to be here and to present the research. So today I'm going to talk about blood smear leukocyte identification using an image segmentation approach. Well, the general problem that it's currently being observed. It's a manual biomedical image processing, mainly in laboratories where they have large data sets, from a microscope or similar products. And this is truly time consuming and can be very reliable on the human. It's okay. On the human error or at his experience, let's say. This can result in inconsistent treatment path or, just like inconsistent results from different researchers in the laboratory. To introduce the topic a little bit, we are going to talk about the microscopic images of blood smear. The dataset chosen for this research was a rabbit VBC dataset due to its large volume and variety of the images. I will talk about the dataset a little bit later on. Actually, the aim of the study is the identification of the region of interest, which is actually identification of leukocytes in the blood smear images. To set up some research goals, the main aim is actually to reduce the manual processing drawbacks, as I mentioned in the previous slides. What makes this study a little bit different from the other approaches which other universities are providing? It's the thing that the other researchers mainly do when they do some image segmentation. Often what they do, it's like they create their own data set, just like they have a data set of, let's say 200 samples, but they just decide to use the 100 samples that are very similar to each other and very clear, they do not have any, just like scratches or just some bad things in the images, essentially. Actually, the aim of the study is to develop a system that doesn't require this. What I want to do is just, you take the all data set and you just run it through the system, and you don't have to selectively pick the good images, because I consider this a time-consuming thing. So this is what we want to exclude from the process. I said I would be talking about the dataset. So I already mentioned the dataset. It actually has around 40,000 sample images in total. But though these comes from two different microscopes, one was Zeiss, and I think the other one was Olympus or something like that. For the study, I decided to take 6 out of 7 albums from the size microscope, which is the 7 albums in total is around 2,500 images. But the 7th album had completely different graphical features. And since we're going to use the image segmentation, which essentially takes the graphical features, so it was kind of impossible to do it for all of them. So that's why only 6. The dataset was also chosen due to JSON annotations, and these would be used for the verification of the whole system, for the proposed process. On this image, we can see on the right side, it's a sample of an image from the dataset. The dark violet cells that we see there, it's the leukocytes. The other ones are the erythrocytes or red blood cells. And on the left side, we can see the annotation. So the cell is actually labeled by 2 experts, and they identified essentially the X and Y coordinates of the cell. So it would be used for the verification of the system, if the system decided correctly whether the leukocyte is in this position or not. The part of the research was also to explore some existing techniques, because the aim is actually not to develop some new technique in image segmentation, but just to make use of the existing ones. So I examined some techniques as thresholding or contour extraction and similar. Since these techniques are available, so they are available in many software solutions or just libraries, so I decided to make use of this. And specifically, I chose ImageJ software because it has many implemented features that I can apply, and it's very user-friendly and easy to use. Essentially, you don't need to read the picture. It's actually just a sample of a macro. And by this, I just wanted to show that you can set up some pipeline of operations. So just like some set of operations apply to image. And it's a very short code, I would say, that you can just save and I don't know, maybe do some modification and apply to each and every image. So you don't have to do this repeatedly. You just have a bit of code and it works. About the operations or the pipeline that I mentioned, here are some main features that I used. I used histogram, RHB channels, some thresholding or dilation, and in the end, I analyzed the particles in order to get the region of interest or the leukocytes. And this depends on some parameters, for example, cell size or circularity and others. To automate this process, essentially, I decided to use a Java application, or I created a Java application in order, or actually what this application does is some preparation of the images. It essentially runs the whole process, to the ImageJ macro and stuff. Actually, at the end, it just loads the CSV files and they can be used for further processing or the evaluation, which is also part of the application. And the evaluation, as I mentioned, is based on the X and Y coordinates both from the system and from the experts as well. To make the user interaction easy, I decided to use a configuration file. This file is actually just a simple CSV file, and basically it includes all the necessary settings. So the user just interacts with one, file, and it's quite simple, I would say. It includes all the parametrical values for measurements and just like everything that user can change in the system. 2 experiments were held to kind of make the solution running and to test it. So the first experiment was just taking one album of the Rabin VBC dataset, which was approximately, okay, I don't know why, but none of the images are showing in the presentation, or at least I don't see any. But that's okay. I can just talk about it. So there were actually graphs, to support the text. Essentially, on these 130 samples, the operations were applied, and I was evaluating the three aspects. There were correctly identified cells, then those that were not identified but labeled by experts, and the third category was the ones that were identified by the system but not labeled in the expert section. So essentially, as the correct ones, essentially to count the accuracy, I used the correct ones, and the ones that were identified by the system but not in the labels. But those had to be examined another way, like mostly manually, because it was just hard to implement in the system if the leukocytes are actually not in the labeled by the experts, because it would kind of like break the evaluation. The graphs would just really support this, but I'm doing my best. I don't know why they are not in the presentation. Okay, the other experiment, as I mentioned, was to just support the solution, and okay, I think that I think that the wrong presentation was uploaded, probably, but never mind. So basically, with the same configuration, it was just applied to a larger set of images, and the accuracy score that I got was essentially 91%, which was just 2% or 1% worse than in the smaller dataset. So I would say that the solution is pretty stable, and it kind of demonstrates the accuracy of the solution. That was the aim, actually, of the study, just to have a large sample, and you don't have to pick the images. So whether you take a small amount or a very large amount, it's just the accuracy doesn't change. About the results, just the results of the system essentially are some CSV files, which actually have the data about the position and some other things about the identified regions. Then some images. I don't know if it's okay. You are able to see this. So some images that essentially have the region identified, and what's here, maybe you would ask why there in one cell there are two marked regions. So that is because the image segmentation just takes the graphical features, so just change the color. But in the evaluation, if these regions are within one cell, which can be compared to the things or the coordinates from the expert labeled cells. So essentially, if they were in similar coordinates, they were just evaluated as one cell. There were, I would say that there were a few exceptions with no cells, and or no cells, or just like a large amount of cells were identified, but this is the error, and this is just like the downside of the graphical feature evaluation, I would say. To conclude this, I would say that the contribution is to diagnose or just like to create a new data set because if the cells are identified, like the region is identified, the doctor or the laboratory worker can just, mark the region of what type of cell is this. So they don't have to specifically search for the regions, but the system can actually find the region, and just they will just mark the cell. That would be all from my side. So thank you for the attention. Sorry for some disruptions with the presentation. It's really not my fault, but somehow I hope I managed to explain.
Questions?
So today, one of the things that we saw in the result.
This one?
So, yeah, because I'm not familiar with the classes. Like the game is to draw the outline of
Actually, the outline would be very hard to get because it's basically the same color as the red cells. So it doesn't differ so much. So it would be actually really hard to get it by using just the graphical features. For that, probably you would just have to train some active learning or machine learning model or something. But using the graphical features, selecting the whole cell is not possible. So you will just select the nuclei. That's the best that you can do. And
how many employees this
well, because basically this region is what was marked in the labels from the extract. So this is just marked as 11 type. So when the system does the evaluation, then we just take the color. So we did it, the two, but it's actually one.
So this is a level side.
Sorry?
It's a leukocyte. This one.
Yeah. So this is yeah, with the dark nuclei. And these are just red blood cells.
So it detects. So this
Yeah.
one division marker detects two.
Yeah, it
The
takes two. But then the evaluation algorithm works that way. That it just takes the region and it examines if the region is a subset of this bigger region. So if I don't know, there were like 3 or 5 and they were all a subset of the bigger region, they would be just evaluated as one cell. Okay. This right there. This one?
So these are used by the district as to determine all of the.
Well, essentially you have the image and you just do sequentially some of these operations and you are able to identify the regions on this whole image.
So these have been done on select or?
In a pixel level, I would say, because you can also you can either mark those as squares and you can also mark the borders. You
And
know?
then how should group together in the pattern return to this sort?
What do you mean by group together?
If these are calculated at pixel level, and then we saw a contour, nice contour again.
It's essentially it also creates a CSV file, and which with both coordinates of the x and y coordinate for every point. And from this, you either, as I said, you either have the whole border, like in one CSV file, so you just have the points, but it creates the whole border. So either you have this, or you just have the top left, the top left point, or you have the width and the height. So you can just calculate the width and the height.
This is from the expert, or also from the humanitarian.
This is from IEEE. This feature
So
that.
when you get where the expert margin.
Yeah, but essentially the aim was not to create the borders, but to create actually the process that is able to get the stuff. If you understand me, I mean this, because because this is a simple code for the operation. So essentially, in order to get from here to here, you have to create a set of operations using the graphical features that will essentially somehow divide this from the background.
So the division is done by inversion in
No, the division, well, partly yes, partly no. The division is just, at the end, it just gets to black and white. So this is the division that image data is doing. So when you see the white thing, he knows it's the self, when it's black, it's the rest. But to get there, it's the process diagram.
But then black and white.
Yeah.
This is a good case, maybe because 1, 2, 3, 4, 5 places of course are big, but in most cases, because many white dots goes together. There's not a big line.
Well, no, it's essentially it is a big nice one, and that is due to dilation. It's a feature or
So it's dilation that unite.
a thing that ImageJ offers, and I can just decide how many times do I want to repeat the dilation. It's also the process for image segmentation, and essentially it works like if you have two, or let's say, okay, I will come back here, and let's say you have this, right? This is very thin area. So in image segmentation, it can often happen that these things just separate, like here. But essentially, the dilate function does that it just takes the border and just like move, I don't know, 1 pixel further, like that. And this is basically what gives the opportunity to connect the pixels that are close to each other and have the white part.
What is it that decides to stop this dilating?
Well, that's up to the user.
How?
You can, because it just I don't know, move 1 pixel or just a very, very small amount, but you can do the operation, I don't know, you can do it once or you can do it 10 times. So that's,
So you decide that at the beginning and then
Yeah.
let it go to
yeah,
that.
exactly. Yeah. Okay. Any other questions?
Very short question. Thank you for your presentation. My question is, I'm not sure that my question is enough correct, but what about data set coverage? I mean, what about capacity of data which you take into account to find a decision or problem or classification of the image? If your decision is based not on neural nets, that's a classical approach to classification.
Yeah.
But in any case, this problem is very
Sure, but like what I wanted to demonstrate in the presentation or in the research itself is to take like a set of samples from a microscope. Like imagine you have a patient and you are examining his blood. So from one blood sample, essentially you get like around 70 images of the blood. So essentially, you will just need to examine these 70 images. But the solution was like created to, or was just tested to a lot bigger sample of the images. So it shouldn't make a difference, if you had like the smaller set. So it should work.
This solution is creating information, new data sets, because from experts we need few market places, and this solution make it on all data sets.
and say new artifacts, new
Yeah.
data set.
Yeah, and they will just label.
A new data set of the blood cells with
labels?
CSV labels in JSON or CSV file, which can be used in another studies in this form.
In my opinion, it would be very nice to get any metrics
They were actually there, but I don't know, the wrong presentation was uploaded. So none of the graphs and our architecture was there. So yeah, so probably just read that.
Okay. Next presentation is from me, and tema is development of tool for monitoring computer user fatigue.
You know what, maybe I was thinking we should have done this. Maybe it was blocking the graphs before. Okay. Share.
Thank you. My name is Josef Kostolny, and my team, last two presentations and me, we are from University of Žilina, Faculty of Human Science and Informatics. And this study is about a design and implementation of computer user fatigue monitoring techniques using eye tracking, camera, or ambient light sensor. The system will analyze user blinks and is needed at what time of day we are blinking, after what time in computer use, or under what lighting. The system will produce data based on which will be possible to identify patterns in fatigue changes and influencing factors. And this data could be in the future used by analyzing by biomedical experts. Okay. Theoretical basis in past years by COVID, every persons or every people on working on computer, and first syndrome or computer vision syndrome is include eye discomfort, fatigue, dry eye, blurry vision, and headache. Mechanism of eye fatigue is external muscles of eye and accommodation mechanism or ocular surface. And external factors we can consider in this study is room lighting. Important factors is lighting affecting on this eye fatigue. How to measure lighting and fatigue? Fatigue occurs with long-term computer and immoper lighting. It is manifested by reduced frequency of blinking of the eyes when we use a computer. Ambient lighting, this level of light intensity can be sent using the ambient light sensor. For this solution, we are design two modules. First is a computer user capture module, and second is a computer use fatigue analysis module. First module consists from hardware, Raspberry Pi microcomputer, web camera, and ambient light sensor. This module produces a video recording of the computer user and CSV file of ambient light level values. And illumination values are in lux and is assigned to timestamps at the moment of capture.
Second module, computer user fatigue analysis module, input these two parameters, video of computer user, which is recorded, and file with lighting values with timestamps. From this input, it will start analyzing of blinking moments of the computer user, and at the end, he connects these movements with a value of lighting and giving time. The output of blinking timestamps file with associated illumination value, and the end likewise the output is a graph of the average numbers of blinking in each minute, and give how during these analyses. Important aspects is ways of detecting eye fatigue. Eye detection in the image, or using facial landmarks detectors. Next is a determination of significant points of the face, and blink determination, A aspect ratio or blinking duration from approximately 100 to 400 milliseconds. Implementation, we use programming language Python and libraries SciPy, emulates Dalip and OpenCV. Physical board with the sensor is Raspberry Pi with ambient light sensor. On this slide is a demonstration of recording of video and blinking my my co-author, and data set of from ambient sensor with timestamp. This data with second module can analyze and creating these two graphs, which is average number of blinkings across the day and average lighting level during the recordings. This is two values which can analyze in the future, and this is a full data set which can be collected with this system, and on this graph is average number of blinkings per minute during the afternoon across 9 days. These are average 9 days afternoon work in the computer, and average or way of this count of blinking is down. In conclusion, aim of this work was design and implementing techniques for monitoring computer user fatigue. Introduce the technologies necessary for development is Raspberry Pi computer, microcomputer, and ambient light sensor, and design on an implementation of this software for collecting data and analyzing these computers blinking. And future works is calibration of face detectors by elimination of tendency to rotate the face or another point of view capturing the face, connecting to a powerful remote server, storing layer which can give us a storing ledger of amounts of data, faster analysis, maybe real-time analysis, or machine learning computing on collected data. And finally, the determination of hidden correlation, which can decide between work of on the screen and maybe some point of view, some lighting. And these works, or one author is from Simon Helteners, and this solution is in progress for producing. Thank you for attention.
Thank you very much, because this picture very typical for our work.
Yes.
My question is the following. I know there are other programs, other tools to minimize the risk of our eyes. They are based on more simple approach, time-oriented and so on, or preliminary analysis of what is this program, and after that support mode of good law. Your approach is more potentially is more accurate, but more complex. And so my question is maybe you can combine your approach and others.
Yes, this is a good idea, but this solution is about creating a system with microcomputer or maybe some low-cost device which can add the computer user, and in the future the system can inform the computer user it's time to change lighting level or some pause in the board because it's bad for eyes or something. This is a cooperation between these working on a hardware solution and software level with medical.
And second question, maybe for future and some fantastic. What about application of embedded chip to understand what is really this is can do
Implants.
maybe idea of Internet of friends.
Yes. Maybe in future.
Thank you.
if we find some respondents. Thank you.
That about putting the cloud or the most powerful server, if you find that it was too much of work for the Raspberry Pi to do the outline of the eyes?
No, collecting of the data and creating video is making by Raspberry Pi, and this data is sent to another with in the future on the server which can produce this analyze because analyze video is very hard task for Raspberry Pi. No. Raspberry Analyze is not on Raspberry Pi. This is the most biggest. Yes. No, it is impossible in this way. But we have some solution. We if we don't record video and these blocking steps use it for analyze and in this moment capture image and analyzing of image is possible making into the Raspberry. But video is a first step and is a good solution, but it's not possible analyzing making on this. Yes.
So the frame with the standard 35 or 30%.
Yes. Frame is standard on this solution. This is.
I saw that this person was
Yes.
like an specialist at this thing, but normally we are going crazy.
This is a future world with
So for the
tracking face being another angle.
what about angle? Does it have to be like the computer still could it be higher or the side?
In this work we using a front face camera, but if it's a change of angle and on screen is visible both eyes is a solution for work.
Maybe segmentation of the eye, is it easy task in general or?
Easy task because not only eyes, but is about finding eyes the first time and mouth for calibrate. This is a face and another steps is counting these Vikings.
Standard of the your standard.
Oh, standard.
And the second question, I have an idea, maybe you can use additionally well-known technique, eye tracking. Did you analyze?
Yes, but eye trackings need special hardware.
It's,
Yes,
it
it's
is not-
Xbox
Yes, it is.
Kinect.
Not a lot of money.
Not money, but this solution is about making with basic camera or low cost camera, because this is a patented solution. I know if you can buy it from China, another replicas, but this solution is under Siemens containers
Yes.
work.
We have experience with eye tracking devices and software, and when come back, we will think about this accessibility. We will keep in touch.
Okay. Okay, next presentation.
Είναι πιο απλή γιατί είμαστε εταιρείες.
Sorry everybody, we accidentally disconnected.
Παλιά με τον Νίκο, άλλο σε άλλο τέτοιο. Πολύ παλιά, πριν καμιά δεκαετία χρόνια. Αλλά μόλις σας είδα. Εγώ μόλις είδα.
So Artem, can you hear us and see us, right?
Yes, everything is okay.
Yes, thank you.
Okay, hello everybody. The last presentation of the day. I hope it will be interesting and fast because we are not academics. Actually, we are companies that run a research project, and we present you now today the results of this. In this paper, we present the results of this project. The name of the project is Control Center for the Well-being of Elders with Intellectual Disabilities. We work with this organization many years, that host people with intellectual disabilities, and we cooperate with them to make some solutions to help them in their daily activities. Yes, this work is about the development of a monitoring platform, because these centers, these organizations are hosting people with intellectual disabilities. They employ them in daily centers, but they also have supported living residencies that these people stay overnight in this register for the entire life, actually. So this is the target group, but what happens at this target group? The last decades, the age expectancy of these people, the life expectancy is becoming higher because the services are better. So this population become seniors, and that was not something that happened in the past. So now they have to serve them as seniors also, not only in the early ages. And the life expectancy today is 66 years for these people, and this is because they have different accompanying problems to their situation. And it's estimated from the people working in this field that they enter the senior age about the age of 40 to 50 years. So because of the physical problems they face and the health problems that they face. So how we can help them? Assistive technologies is a sector that works to provide solutions and technical help to these people. And in order to improve their daily life and their well-being. The goal of the project is to research the market for products that are commonly used by all of us, but can be used to provide some data to assist these people in their daily lives. So we tried to find, we had in mind that there are such wearables and sensor devices in the IoT field, and we organized focus groups with experts from this organization all over Greece. And we discussed the problems that the people, senior people with intellectual disabilities face. And elaborating the results of this focus group and their needs and challenges they face in everyday life, we try to match these needs with data from wearable devices and sensors in the market. So some indicative measurements that they found useful for knowing them for these people is common things like step counting, acceleration. These acceleration measurements can help for fall detection and shock detection, because these people suffer from epileptic shocks. So, and other measurements like heart rate, body temperature, GPS location, because they can move around the city. It's not so they are free to go to shop something, but sometimes they get lost or they don't come back at the time that they should. So it's important to have GPS positioning, for example. And other for indoors, indoor sensors that can be useful are simple sensors like motion detection in places in the house that they shouldn't go, for example, at specific times of the day, or door sensors that we can monitor if they open the door or if they open the refrigerator door, or some other things, some other places in the house that they shouldn't. It's not the proper behavior to do so. So, but we had a limitation on which sensors to use, because a lot of these sensors, a lot of wearables that you buy for yourself in the market, they don't give you the data directly. They send the data to their servers, so the data get out. They're not so secure. And the GDPR problems that we face today led us to search for wearables and sensors that they give the data directly to us, okay, as the developers. So, okay. So a few things about the architecture of all this solution. There are some prerequisites, some things that we had to consider when building this. We had to have, to get the data from the sensor. So we need a way to these sensors to send to our server the data. We developed APIs and we program the devices. I will tell you more about the devices in a few moments. So we had to develop an API that these devices you will use to send the data. We had to send alerts because when we find some things, we had to alert the caregivers. So we had to have some APIs to SMS and email services. You have to have a secure database, and you have to have also a rule system for creating personalized rules for each individual. Because, okay, you have the data, but the data doesn't mean something. It's not the same for me and for you. Maybe I have a bigger heart rate, you have a lower heart rate. So it's not always the same rules for sending alerts. So we researched different sensors in the market, and we concluded to two solutions. It is the one device used a lot in research project is E4 of Batica. It's a company that it's famous in the to academia doing similar research projects. And we use this one, and we used a watch from the market. It's the one I wear today. It's a TicWatch. It's called TicWatch Pro. It costs about 200 something euros. Okay, it's not so expensive. The good thing with this watch is that it can connect to the Wi-Fi directly and can send data to your server. You can get the data from here without any intermediaries. So we use these two kinds of sensors because this one uses directly the Wi-Fi. So there are people with intellectual disabilities that don't have and not allowed to have a mobile phone with them. So the smartwatch, the wearable device should send the data through Wi-Fi. But there are others that they can't have a mobile phone. So, and the second one, the Empatica solution, uses the mobile phone, cannot send data directly through Wi-Fi to a server. So we selected these two different devices. And we also developed some door sensors, motion sensors of our own. We developed them. It's easy to develop, taking some microcontrollers and things like that. To do some tests, it's very easy. So, okay, we give these wearables and we install these wearables in the houses that these people live, supported living residences, they call them. And we start getting real data, live data, from the wearables and the sensors installed in the houses. Okay, and we could see live data. Okay, but the system is not to see. You cannot be over the system all the time and see live data. So we created a system for making rules, personalized rules for each individual. So we could make a rule for each measurement of each device. So we could select, for example, this watch, and we can make a rule for me that I have this watch for the heart rate, for example. So you can choose for each wearable, for each measurement, to create a specific rule for the person carries it. And when you select the measurement, then you can apply some functions on the data, real-time data that this sensor or wearable gives to you. So we have some functions, count, sum, simple functions, not something very difficult. And then we have comparison operators.
So, for example, we could create the rules that when we have 10 heart rate measurements in the last minute, in the last 2 minutes, 10 heart rate measurements over 100, then this is an alert. So we give this to the user, to the caregiver. We don't do these rules ourselves. The caregivers that knows the person can create these rules and change them on the way. So we had all this system to create all these rules. And at last, in this personalized rule is the notification. What notification to send? You can even customize the message that you will receive. For example, Nikos is having an epileptic shock. Okay. So, and you select how you will be notified, via email, via SMS, because some rules can be for simple things that you want to know for a person. For example, and if I tell you that what we find, if I wake up at night and go to the refrigerator and open the refrigerator, okay, I want to know this. I can create a rule for this because some people, they have problems with, overweight. So, but you don't want to receive an SMS for this at the night. You can just receive an email at your mail. So you can even customize the alerts. We run the platform in this organization, to Ergastiri. This is the name of the organization that hosts supported living residencies. It moves a little, okay, but we have the right to publish these images, no problem. So they wear the people with intellectual disabilities wear these watches. They accept, because one problem is if they will accept to wear these watches. So they accepted to wear this. They liked more this one because it's more common. They have seen this to other people, to their caregivers. So it's something that they take easier than the other one, the Empatica one that has no screen. So this is important to consider when you go to these people, to give them something that is not that's common, that they have seen in other people and they would like to have. So, and the results, okay, running this program, we found some things that the caregivers didn't know. And these things were night visits to the refrigerator, because this is something that they wanted to see from the beginning. So we had data showing this. We had motion detection on the room of the person, and after some seconds or minutes, the refrigeration door opened. So you could understand that at night, this person wake up, and then the door of the refrigerator opened. So this person went to the refrigerator. So this is something that we saw, and we also identified some light shock, epileptic shocks during the night, that the people suffer from them, had these epileptic shocks, but nobody knows because it was not so severe, and they cannot be detected because at night they sleep, everybody sleeps, so they didn't expect to see this. So this was something that was revealed from the use of the system. Yes, that's all. This is the team that worked for this project, and it was co-financed by European Union by a program that ran in Greece, Greek research program called Research Create Innovate, and it was 80% funded. 80% funded. Thank you. If you have any questions, I'm happy to answer.
Time for final questions. Okay, maybe I started. For this watch is made Google warehouse application for collecting this data.
Yes, I have it.
And my question is, all these sensors is open for collecting from this app, or is some limitation? Or You collect only heart rate.
We collect what it gives. Because all these smartwatches, they have some measurements that there are no raw measurements. They calculate themselves. They have the data from the raw data and then make calculations and present you another measurement. For example, these measurements, they don't give them. We get the heart rate, steps, acceleration data, oxygen level. This one gives oxygen level. The Empatica one gives also EDA. It's electrodermal active. Just a moment. I have it here. Just remember it. So where it is. I have it for sure here somewhere. Here it is, nice. Electrodermal activity. It's like galvanic skin response, it's also named. It's how wet sweat is the, so we have body temperature and things like that. But we don't have, for example, how tired is the user. Maybe some watches say you how tired you are, but this is not given to us. We get only raw data from sensors that are on the
battery.
Yes.
Because if this whole data is collecting and sending, it's
yes.
decreasing.
Thank God, this one is a new one and with the long battery life. It says about 20 days, but in smart mode, it's 1 to 2 days. It's not so much, but it's good enough to be used for this work. I mean, and the persons, I have pictures not here, they charge them by themselves. They liked it and they did it. But they also have their caregivers, that the caregivers can help them in charging. So battery life is a very important issue in all of this. Yes.
Okay, thank you.
So you collect the data of the box. You send it to the server through Wi-Fi modem or mobile telephone?
Through Wi-Fi. Not, yeah, no, okay, yes. And through the, or mobile, yes, because the one, yes. Yes, we do. We do encryption because we have a GDPR behind a whole process for GDPR made by University of Aegean that we follow to send data and store data. And actually, we don't have the data outside the organization. There's a server inside the organization. And so the data gathered through the Wi-Fi network. It's inside the organization, yes. No. They could go also there, but not, because they have the infrastructures to have a server they also already have a server inside, so we don't have the data outside. Yes. Yes, there it's another. It's the GPS location. It's through a SIM card. You need a SIM card. Yes.
So it's necessary.
Yes.
Because you watch.
No. Then you have to be connected to the mobile phone.
So the innovation of that. What is what?
The innovation is.
Collection of different data.
Yes, the innovation is that we have a system that many wearables can be connected to this system. It's quite modular, and you can add a new sensor as a user. You can say, I want to add this sensor with these measurements, and you connect the sensor, the new sensor. You program it, of course, but you connect to the platform and gather data in the same place from different sensors. You don't have a system for each sensor, a different system. You have a system that monitors everything. And you can create the rules creation system is very interesting because it helps in order not to be over the system all the time. You get alerts.
Support system.
Yes, something like that, yes.
Thank you.
Okay.
This was a final lecture presentation. This session is now closed. Thank you for having me.
Thank you.
Thank you for the interesting.
So thank you also for the online audience. And we join again tomorrow according to the program, 9 o'clock for the plenary session. So that's all for today. Have a nice evening.
Okay.
Yeah.
Thank you too.
There is a suggestion to make the protocol.